Hello class, and welcome to your 11.7 notes. After studying this section, you will be able to find the ratios of areas by calculating and comparing the areas and applying properties of similar figures. There's a mouthful. And I apologize, I know that there is a glare on this, but I'm hoping it will be better than nothing at all. So today we're just comparing areas. So if I calculate the area of this triangle, 1/2 the base times the height, I would have half of 12 is 6 times by the height 8 is an area of 48 units here. And then base times height for a parallelogram is an area of 90 units squared here. So the work that's on here, even though these slides look a little overwhelming with how much information on there, is just comparing the area of the parallelogram to the area of the triangle on bottom. So 90 out of 48, and that could reduce to 15 out of 8. So ratios compare two different items in a division. The first example you're given asks you to compare if AB is 5 units long and CB is 2. And we're actually going to compare these two triangles right here. Since these are both kind of along the same parallel lines, they have the same height. They do have different bases, but they have the same height. And so this says the area of triangle ABD compared to the area of triangle CBD. So ABD is on top. Those are both going to be 1/2 base times the height. I'm adding subscripts of 1 and 2 to these just so that you know which triangle I'm talking about. So I'm going to call this one triangle 1 and this one triangle 2. All right. So 1/2 divided by 1/2 is going to go away. The height is the same, we already said, so that will go away. So my ratio for these two is just going to be my first base divided by my second base, or in other words, 5 divided by 2. Okay, this next slide has a lot. Let's just ignore everything else and focus on this side right here for a minute. So these two triangles are similar. Similar triangles have the same ratio. So I could look at this side and say that the ratio is 3 to 2. So 6 divided by 4. If I want to get over here, I'm going to have to multiply anything that goes by 3/2. Okay? So if this side length was 10, I would multiply by 3, which would give me 30, and divide by 2. So this side length would be 15. Similar triangles always, no matter what their side is, has the same ratio. Let's keep that in mind as we go to talk about how to compare the areas. The area of triangle PQR is 1/2 the base times the height. Notice that 1/2 divided by 1/2 for the second triangle's area is going to be the same. So that will just divide to 1. All I'm left with is base times height. The base of and height of the large triangle, and then the base and height of the smaller triangle. Now it's time for us to think about this rule that's written down. If two triangles are similar, the ratio of any pair of their corresponding altitudes, medians, or angle bisectors, altitude meaning height, equals the ratio of their corresponding sides. So just like the sides had corresponding ratios, the height of these will be the same. So if this was a height of 2, I don't know that it is, but if it was a height of 2, this would be a height of 3/2. All right, so always the ratio, the base 1 over base 2 is 6 over 4, which is 3/2. The height is going to be the same ratio, 3/2. That allows me to come and plug into this formula for my ratio, 3/2 times 3/2, 9/4. Okay, got a little confused there? Then just remember this rule. We're going to put this into a formula for you. If I want to compare the area of similar figures, underline that word similar figures just so we know it only works for those two, I'm going to take the ratio of the sides and square it, always. Given the similar pentagons, find the ratio of their areas. I'm comparing areas, so I'm going to take the ratio of the sides, 9 and 12, and square it. Now, when we work on this, go ahead and simplify inside the parentheses first. So both of those divide by 3. 4 over 3 squared is 16/9. That's it. So easy. This messed up on the slides. This should say that triangle ABC is similar to triangle DEF. Find the ratio of the areas of the two triangles. Okay, so we're talking about area here. Go ahead and why don't you guys pause this video, maybe try example 1, 2, 3, and 4, and then come back and check your work. I'm going to put triangle ABC on top. They didn't really say which one needed to go where. It's going to be 12 over 8 squared. Both of these reduce. So the ratio of the areas is 9/4. If the ratio of two similar parallelograms is 49 to 121, find the ratio of the bases. So in this case, we said that the ratio of the area